Quadratic equations can be written as expressions raised to a power of 2, or in this case we could say x plus 2 squared. And it's important to know that originally quadratics were modeled by drawings that represented squares and rectangles. And today we're going to represent these areas for these quadratic expressions using squares, but it's important to understand how we make these squares that we're talking about, because today's lesson is all about building a perfect square. So we're going to be using algebra tiles to build this perfect square. The tiles we use are shown above. This blue square represents our x squared piece. Okay, when we talk about algebra tiles and x squared, we're talking about the area of this tile. So the length and the width of this tile are going to be represented with an x, and x times x gives me an area of x squared. Now these green rectangles, they have an area of 1x. The long side is the same length as our blue square, so this side is going to be represented by x, but the short side here is going to be represented by a 1 because it's 1 unit. So if we find the area, 1 times x gives me an area of 1x. And then finally we have this little yellow square. That represents an area of 1. So the length of 1 and the width of 1 would give me an area of 1. And what we're going to do today is we're going to use these algebra tiles to create perfect squares, and we're going to look at how this area represented by this perfect square is actually representing a quadratic expression. So here's a quadratic expression we're going to look at first. X plus 2 squared. When we think about this, what we're looking for is the square of x plus 2, the square that's represented when we have x plus 2 as a length and x plus 2 as a width. So I'm going to set this up as a multiplication problem, x plus 2 and x plus 2, length and width, and we're going to multiply these two sides together. So if I start off here and I have this x times this x times x gives me x squared, which remember, x squared is represented by this blue square here. Next, I'm going to multiply this x times 2, which means I have two 1x pieces. So 2 times x are going to give me these two 1x pieces. So remember, this is my x squared, this is 1x, and this is 1x together. That gives me my two x's. Now we're going to continue this multiplication. We're going to multiply this x times this 2, and we're going to get these two pieces. I had to turn them sideways because remember, we're trying to make a perfect square, but this is still 1x and 1x, which gives me my 2x. And then finally, the last thing we're going to multiply here is 2 times 2. 2 units times 2 units will give me 4 units. Okay? And remember, each of these pieces is 1. So this, what we've done here is we've created a square that has a length of x plus 2 and a width of x plus 2. And you may be thinking, well, what does that do for me? How is that useful? Well, what we can do is we can take this and use what we call the box method to find the answer to this problem. So what we're going to do is we're going to take this idea of this model and we're going to do it out mathematically over here. So I'm going to do x times x is going to give me x squared. And then mathematically, I'm going to multiply this x times this 2. 2 times x gives me 2x. Since it's a positive, we'll say plus 2x because we've got a positive times a positive. I'm going to do the same thing down here. I'm going to multiply this positive 2 times this x, which will give me plus 2x. And then finally, last but not least, I'm going to multiply this 2, positive 2, times this 2. 2 times 2 is going to give me 4. So the answer to this area, or the answer to this quadratic expression, is going to be what I get when I combine all these like terms. So I only have one x squared term, so I know I've got x squared. Inside this box, I have a 2x and another 2x. 2x plus 2x is 4x. And then finally, the last thing I have in this box right here is a plus 4. Now let me show you how our model and our box method actually gave us the same answer. So this blue x squared right here, this blue x squared, is represented over here by this x squared box. This 4x is represented right here. 1, 2, 3, 4 x's. And then finally, the last thing I have, this plus 4 here, is represented by the 4 boxes I have here. 1, 2, 3, 4. So that is how we can use the box method and the models to create our perfect square and find out what the area is of a square that has a length of x plus 2, or we can say, what is the area of x plus 2 squared? We can do one more here. X plus 3, we're going to follow the same model. So what I'm looking for is, what is the square of x plus 3? So we're going to set this up. We're going to set this up. Remember, it's a multiplication problem, our length and our width. And we're going to start off. We're going to do x times x, which is going to give me my x squared. We are going to do x times 3, which will give me my 3 1x pieces here. So remember, this is x squared. This is 1x and 1x and 1x. So my x here on the left and my 3 on the top gives me 3x pieces. I'm going to do the next x times 3, which will give me this 1x and 1x and 1x. And finally, I do 3 times 3, which gives me all of these 1s right here. Okay, so if I wanted to now use our box method, this is my representation with my model. Let's represent this algebraically using our box method here. If I do x times x, I get x squared. I'm going to do x times 3 right here. X times positive 3 will give me a positive 3x. I'm going to do this x times this positive 3, and I'll get a positive 3x. And finally, last but not least, I'm going to do 3 times 3, which will give me 9. Now let's combine everything together and see what we got. I have an x squared here, which is my x squared, and if I look over here on the left, that's this x squared right there. I'm going to look at all my x's now. Remember, these two are going to combine together because they're like terms. I have 3x and 3x. 3x plus 3x is 6x. And then if we look at our model, we can see that 6x. 1, 2, 3, 4, 5, 6. And then finally we'll finish it up with right here, plus 9. And that plus 9 is represented right here with all these 1s. And that's how we can model a quadratic expression and find a perfect square.